All right. Hey, everyone. Thanks for joining our bi-monthly or every other month community call. We really appreciate you joining us in our new format here. Hopefully this will allow more folks to join, with it being earlier in the day and more East Coast and European friendly. So we're excited to have you all here and look forward to you joining us next time as well. So just getting started with a few bookkeeping things, if you will. This is a community. We expect folks to apply or honor our code of conduct. In short, I mean, I'll give you a second to read this, but in short, just be a good person, be nice. Don't respect other people's opinions, and all of that stuff. So. All right, I'm going to assume you're all super fast readers and have read through that and are going to be good people, and we're going to have a good conversation here. So, just speaking of good conversations, you're all muted right now. We do, and I'm assuming Ned is okay with it as well, but we do want this to be an interactive meeting. So you all have the ability to unmute yourself. If you have a question, feel free to pop yourself off mute and ask the question. If you're not comfortable kind of going off of mute and asking the question, feel free to do that in chat. So we'll be answering questions in chat or live itself. So we really do want this to be interactive throughout the whole thing. So we've got a short but action-packed agenda today. We have Ned here to talk about some exciting OIDC stuff, and then Steven's going to talk about some not open source, but so the format that we usually have is we go through some updates on some of the projects that we're doing from a Terraform on Azure perspective. And then we talk about some other related topics. And today we're focusing on the related topics. Not that we're not doing stuff from a Terraform on Azure perspective, but we don't have any big updates. So we thought it would make more sense to spend time on some of the other not peripheral, but non-project related topics today. So from an overview perspective, for those folks who haven't been on these calls before, just a quick overview of what our team does and what our team owns. Our team is part of the Azure deployments team here on Azure. What that means is any of those tools that you use to manage Azure, everything from the portal to the imperative tools like PowerShell and CLI to the declarative tools like ARM templates, Bicep, Terraform, Ansible, our team is in charge of. Stephen and I and Jingwei, who's another PM that's not on the call today, but we all focus on Terraform. So making sure that your experience on Terraform, you can do everything that you want to do on Azure using Terraform. That includes everything from the Azure ARM provider to other providers like the Azure ADO provider and the Azure DevOps provider, the Azure AD provider, the AZ API provider, tooling around that with the Terraform export, and anything else related to Terraform on Azure. So we really try to make sure that you can have the tools and the providers that you need to be successful. So, and the other thing you get with us being part of the deployment team is consistency. So the teams that own the deployment products are working to ensure that we have consistency. So your experience using Terraform should be consistent with your experience using Bicep and PowerShell and CLI as much as they can be, being different technologies, if you will. So, all right. We are focused on community. This is one of the areas that we really want to try to improve and grow in the coming years. We have been fully focused on making sure that the Terraform experience on Azure has gotten better and better over the years, and hopefully you have felt that with the coverage from an Azure ON perspective and some of the other areas that we're investing. And we really want to make sure that we build the community, everything from contributing to the projects that we work on, to giving us feedback on those products, to everything in between. We are investing in Terraform because it is important to our community. So we want to make sure that we are working with you in every way that we can to ensure that we are doing the right things and investing in the right areas. So some of those areas that we are investing in or kind of beefing up from a community perspective, hopefully you've seen it, but we have started doing a regular blog post. And this is the intent of this is to ensure that all of you are aware of everything that's going on. What we found in some of the customer interviews that we've done is some of the biggest problems that our customers have, we have addressed in one way or another, but you may or may not know that we've done that. So we really want to put out on a regular basis a blog post that highlights some of those things, or not some of, all of those things that we're working on. These community calls, we are kind of spinning back up from a COVID perspective. We kind of had a bit of a lull there and didn't have a lot of community interactions. So we are spinning those up again here. We've done 2 or 3 prior to this. Those ones were, we kind of started out with an attempt to do live community meetings, hoping that we'd get people in person. But from a time perspective, it was evening in the Pacific time. So it kind of excluded a lot of folks from the East Coast and Europe and all that. So we're kind of pivoting on that, trying to make them earlier. If we get a good turnout here, we'll keep that up. If we get feedback that we kind of want both, we can do that potentially in the long run, but we really want to make sure that not only are we putting the information out in a blog perspective, but we're actually reaching out and having conversations with you all, so that we give you an update on what we're doing, but we want to hear about what you're doing as well. We've also just released, so we've done some customer surveys and had customers sign up for our community. And that community has grown pretty extensively. We have over 500 people in that community right now. And to date, that community has consisted of us having their email address, which doesn't seem very productive for anybody. So we have started a community channel, or a community Slack channel, that there's the link there that anybody can join. We've invited the folks in that community to that Slack channel. But that is a channel that's focused on, or a community that's focused on Terraform on Azure. We will send or post updates to that occasionally. We'll have conversations. We will answer questions that you folks have. If you're getting blocked with something, we have a channel for you to ask for help. Some of our devs are on there. So we really want to use that as a way for you to communicate to us, as well as us to communicate to you, and for you to communicate with each other. So a lot of times the community is able to help out other folks. So we just want to extend our initiative of making sure that you're successful using Terraform on Azure to the whole community. So we really hope you join that and join the conversation there. And lastly, we have always been, like I mentioned, we do this and we invest in Terraform because the community is interested in that and wants that. We've always had customer interviews to get feedback. We will continue to do that, and we will post in the Slack channel and ask for your feedback in community calls and all of that to get your participation in those. But we do that on a pretty regular basis for anything from new versions of things that we're working on to net new products and investments that we're working on that we want to get your feedback on. So we will continue to do that and encourage you to participate in that as well. All right. From there, I will hand it over to Ned. Ned is volunteered to come and talk to you all about some the OIDC auth from a Terraform perspective on Azure. We have put out there, Stephen put out there a little while ago in the community that we have, that this community call, we want to not only be us talking to you as the community, but we want you to be able to share with each other as well. And Ned volunteered early on to be kind of one of those experts and share some of his experiences. So we were excited to have him on and talk to that. So welcome, Ned.
Thank you very much. I'm excited to be here and to present on one of my favorite things, which is using OIDC authentication with Terraform and Azure AD, or really just using OIDC auth everywhere, because I don't like static credentials. Static credentials are stinky. I don't like them. Because, well, there's like a whole bunch of reasons why I don't like static credentials. One is that they tend to be really long-lived, and they have the propensity to be leaked. And of course, leaking credentials, that's bad, right? The other problem is typically getting credentials from your security team. So imagine you're a developer or an infrastructure person, and hey, I need credentials to be able to provision this Terraform infrastructure in Azure. And somebody goes, okay, I'll put together a service principal and ship it over to you. But that's going to be like a week, right? Because I got a lot of other stuff to do. I've got tickets. So next time you need credentials, like, oh, man, I don't really want to go through that process again. So I already have these credentials. Hopefully they have access to this other subscription. I'm just going to reuse them. And what happens is the person who manages that service principal may expire those credentials, and suddenly everyone's deployments break because that credential has been passed around to a whole bunch of different people and reused. So that's generally not great, because now it's been reused a bunch of times, which means that there's a better chance it's going to leak. And if you do try to rotate the password for it, you're going to end up breaking a whole bunch of people's stuff. And you really don't know what that blast radius looks like. So because of that, I don't like static credentials. So what's the alternative? Dynamic credentials. And that basically means, if I could kind of define what I mean by dynamic, is that the credentials are provisioned on demand, which makes them fresh. They're always fresh and new. You're not getting stale old credentials that have been used in a bunch of different places. You're getting a new set of credentials every time, and that is available for a limited amount of time, or it's valid for a limited amount of time. They expire by design. And so previously, when something would expire with static credentials, it would break a whole bunch of stuff. But if you know upfront that I can get new credentials when I need them, and these are designed to expire, then you're going to develop your processes around those two things. And a lot of the times the credentials are intended for single use. Now, when I keep saying credentials, right, and I don't necessarily mean the service principal itself, because as we'll see in the demonstration and the whole setup process, you're still going to need to set up a service principal in Azure, unless you're leveraging something to dynamically provision that, and that's like a whole other talk. But you are going to be creating a service principal in Azure that has specific permissions to work with different subscriptions. What's dynamic about it is, instead of setting a static password, now we're going to be using federated credentials, which basically generates a token that has a limited lifetime associated with it. So that is the portion that's single use. That token is really for this one run in your automation software. And when that run is over, that token's going to expire. And if it got leaked or someone got wind of it, they can't reuse it because it's already expired and it's useless to them. So I like that portion of it. I like the dynamic credentials. So we're going to walk through an example where I'm using GitHub Actions to deploy Terraform configurations to Azure. And in order to do the authentication, I need to work with Azure Active Directory. Now, what are the options that you have out there if you wanted to use GitHub Actions with Azure AD and Terraform? Well, the traditional way to do it would be to store your credentials as a GitHub secret associated either with the repository or with individual environments inside that repository. So that was the simple and easy way to go about it. Yeah, like I said, you store that per repo, per environment, and they're static. And we've already kind of reviewed why static isn't great, but I mean, it's not insecure. GitHub does a good job of securing your credentials. It's not going to leak them out. You can't even view what the values are once they're stored in secrets. You can only update them with new values. So that part is nice, but it's still static credentials that get reused a bunch of times. Another option that you have available to you is to use self-hosted runners and a machine ID. So in this scenario, you would have virtual machines running in Azure that have a managed security identity associated with them. And when a job is running from a GitHub Actions, it would select a runner that has a machine ID with credentials to perform the actions in the target subscription. And in that way, it is more dynamic because that machine has to exist and it leverages its trusted relationship with Azure AD to provision temporary credentials to do its work. The downside is you're now self-hosting runners. So you're going to need to care and feed those virtual machines, keep the version of the GitHub agent up to date. Because of the nature of managed security identities, you're going to need multiple virtual machines for the different subscriptions you might want to manage with different identities. It can quickly become a bit of a management nightmare. So the third option, and what I'm going to kind of walk through today, is using OIDC-based authentication with GitHub's own hosted runners. You can still use self-hosted runners if that's a requirement in your security landscape, but you no longer have to rely on their machine ID. You can use the trust between Azure AD and the GitHub token service to provision temporary credentials for every run of GitHub Actions. So that it's also a dynamic option, but this one is a little less overhead for you to manage on an ongoing basis. So before I had ever used OIDC and JWT, which I'd never even heard of before, I remember this clearly. I was in a meeting or a conference call with this cloud native company, and they kept talking about the JOT. Well, we need to pass around the JOT. And I was like, what, are they saying JOT like J-O-T? Or do I need to jot something down? I don't understand what's going on. I was like, well, it's kind of like John, maybe. Maybe this is kind of like a Philly thing. No. It was how you pronounce JWT, which is the JSON Web Token. And that's kind of the currency of exchange that happens within OIDC. So I thought I would just kind of step through what the process would look like from GitHub Actions talking to Azure AD and the runner that exists in GitHub Actions and how it passes all that around. So everything kind of starts with the GitHub token service. So the GitHub token service, when a GitHub runner is spawned and given a job, it can also get a token from the GitHub token service that has some information in it. And yeah, I know JWT is an abbreviation for an abbreviation for an abbreviation. I'm pretty sure it's just turtles all the way down. So the GitHub runner would get a token from the GitHub token service that it requests. So it has to ask for that information from the GitHub token service. And contained within that token is information about who issued that token. That would be the issuer. In this case, GitHub's the issuer. It handed out the GitHub token service is the issuer. Who is the audience? Who is this token intended for? Who is the GitHub runner going to hand this off to? In this case, it's going to be Azure Active Directory. And then subject property. So the subject is going to correspond to the repository. It might also correspond to a specific environment in that repository or a reference tag, or it could be that it's a pull request, but it's going to have some subject in there that's part of that token. It's also within the request that the GitHub runner sends off, it grabs some secret information it has from the repository secrets or the environment secrets that includes the client ID, the tenant ID, and possibly the subscription ID. All that information is sent on to the Azure AD tenant that's identified within the request. And now Azure AD is going to go through a verification process for that token. So it's first going to make sure that service principal actually exists within the tenant. And then it's going to look for federated credentials within that service principal. And you need a federated credential that has a subject in it that matches the subject that's in the token. If all of that lines up, then the last thing that Azure AD does is it talks back to the GitHub token service and says, hey, I got this token. Is this a valid token? Did you issue this? And as long as the GitHub token service says yes, then the whole authentication process is now complete. And now Azure Active Directory will issue a token to the GitHub runner that allows it to actually interact with the subscriptions it has access to in Azure. So you do need the client ID and the tenant ID, but you don't need to store any kind of password within this whole process. It's relying on the trust that exists between Azure AD and the GitHub token service, and then the trust that exists between the GitHub token service and the GitHub runner issuing that token. I kind of mentioned the claim fields briefly, but I'll just go over them quickly once again. So this is stuff that's in the token that you'll see. The subject is the subject of the token. So usually that's going to be the repository that's the GitHub Actions is running from, as well as a particular environment or if it's a pull request. The audience is the intended audience of the JSON Web Token, and this will be defined by the recipient of the token. So Azure AD has a pre-filled one that I don't recommend changing. And then the issuer is going to be who issued that token, and that tells the recipient of the token, in this case Azure AD, here's who you should go talk back to and ask if they actually issued that token and if it's still valid. And as long as all that checks out, then we'll get our credentials that we can use. Okay, so that's enough slides, right? Let's get into the demo. So first, we'll review what the setup looks like on the Azure Active Directory side of things. Then we'll look at what the setup looks like on the GitHub repository side with the different actions that I have configured. We'll create a pull request against that repository. We'll create a new branch, make a little change, create a pull request. That'll kick off an action. We'll see how that action runs. Then once that pull request has completed, we will merge the PR into the main branch and see that that kicks off a secondary action. And then we'll all go eat tacos because I'm hungry and it's lunchtime. I'm on the East Coast, so it's like 12:30, prime taco time for me. So let me go ahead and share out my screen once I figure out how to do that. There's a share button and there's a screen. So if Mark or Steven just wants to confirm you can see my screen. Okay. Whew. All right. Major technical hurdle has already been crossed. We're good. Excellent. All right. And if this is too small for anybody, just let me know. I have it bumped up to 133, but I can go bigger if it's hard for anyone to see. So before I do any of that, I have a repository on GitHub that's called GitHub OIDC Azure Setup. And that's what I use to actually set up everything that you're going to be seeing. So if you happen to, I can share that link in chat in a little bit. But I use the simple setup, which just creates creates one service principal in Azure AD. I can just show it real quick. We're not running behind or anything. It creates one service principal in Azure with two federated credentials associated with the repository, and then grants it contributor access to a subscription in Azure. And then it also creates a storage account in Azure. So we're actually going to leverage this for storing our state data as well as creating resources within a subscription. Oh, thank you, Ian. And then this also creates the secrets on the GitHub side for you. So you don't have to go through the monotonous process of creating, what is it, like 6 different secrets. It just does it all for you. So again, I think someone's shared out one of them, but I'll share out the other one as well. There's 2 repositories involved here. This one is just to set everything up to make your life a little bit easier. So let's look at what we actually set up on both sides. So on the Azure side, in Azure Active Directory, it created an application and a service principal. And if we look in these certificates and secrets for this service principal, it has no certificates or client secrets. Those would be static credentials, and try and stay away from them. But it created 2 federated credentials on here. And if we click on one, we can view more properties of it. So it already has a bunch of pre-canned issuer type scenarios. So if you're using Kubernetes or customer managed keys, or GitHub Actions, it's got some fields that are predefined for those different scenarios. You can also go with other issuer, and it just gives you carte blanche to put whatever in there. Even though I created this with Terraform, it knows that it's GitHub Actions somehow through magic. So it sets everything up properly. One of the things it sets up for you is what the issuer is, because the issuer is always going to be tokens.action.githubusercontent.com. So that's the address that it reaches out to validate the token. The organization is going to correspond to either your GitHub org or your individual account, where the repository is the actions will be running from, then the repository name. And then you have, like I said earlier, a couple different options for an entity type. So this could be a particular environment, a branch, it could be a pull request, or it could just be a tag. So you could have this, you could have an action that kicks off when you cut a new release. And then that release tag is included as part of what's going to be in the subject that gets sent with the token. And then based on the selection, I said this is for the main branch. And then it builds this subject identifier based off of the information that I've provided it. So it says the repository that includes my account, and then the reference is going to be a reference to the main branch, the head of the main branch. So that is automatically generated for you. You can manually edit it if you want to, but probably not, because then it's just going to be more confusing. One thing I will say is that the subject identifier, as far as I know, unless something has recently changed, doesn't support any kind of wildcards. So you can't have this be for all branches. You would have to create a federated credential for each environment, tag, or branch that you want to support. That's not a huge pain, especially if you're doing it programmatically, but it's just good to know in the back of your head for now. And then in the credential details, the only big thing in here is going to be the audience. By default, it gets set to Azure AD Token Exchange. You can configure that. I've never come up with a reason why you would, but that's what's going to be in the audience field for the token that gets issued to the runner. So that's everything that is in the credential. And because I'm going to be doing this through both a pull request and then a merge on the main branch, I had to create 2 different subject identifiers. So 2 different credentials here. The -PR is for the pull request, and then the other one is specifically for when I merge that change into. Does anybody have questions before I move on to the GitHub secrets side of things? All right. And if you do, pop them in chat, because I got that open on a separate screen. I can see if someone does have a question.
Sorry, I'm gonna interrupt real quick. Aiden, did you raise your hand in accident, or did you have a question?
Yeah, no, it was on purpose. I was just curious, because you talked about creating some of those programmatically, right, tied to a branch or a tag and so forth. What have you seen kind of at scale, like an enterprise scale? Because obviously that can get rather long or a lot of items to kind of manage, right? Do you find that enterprises will create them like a one-off or for that one purpose, and then once they maybe are complete, they'll destroy them and kind of reissue them, recreate them each time? Or
No, they seem to be more permanent than that.
Okay.
So as you're going to have an initial setup process that probably already exists when you're establishing a new repository and deployment. So part of that setup process would be to identify whatever your code promotion strategy is, whether it's through branches or tags, and then just create those federated credentials for each whatever scenario you want to support. So you could bake that all into a Terraform configuration. You can create the repository with Terraform if you want to. And then there's no downside to having these federated credentials, like a whole bunch of them live here, just because there's no active credential, there's no like active password here. It still relies on GitHub Actions to actually talk to and provision that token. So as long as you're controlling access on the GitHub side, that's where I would focus security efforts beyond this.
Cool. Thank you.
Yeah, absolutely. All right. Over on the GitHub side, so I've configured this all to work with this repository, which is the simple OIDC testing. And that's the link that Ian shared in chat. While we're here, I might as well grab the other one. GitHub and what did I call it? Well, if I just go to my main page, it should be right there. There it is. This is the setup one. Got that in chat. There we go. Okay. Before I forget, because I can be a little forgetful. Okay. So I think the easiest thing to start with is looking at the settings here and the secrets that have been created. So again, I'm doing this without environments, but it's all going to be stored down in secrets and variables under, and this one's going to be under actions. And I have 6 repository secrets here. So these secrets are going to be available to GitHub Actions when it goes through a run. So I do need the client ID that corresponds to that service principal we were just looking at. I need the tenant ID where that service principal lives. The subscription ID, I really need that to perform any operations in Azure. And then the container name, resource group name, and storage account are for the storage of state data. So I'm using the credentials that I get from the federated credential to access the container that's in Azure storage to store or access my state data for this configuration. So I'm kind of using it for both purposes. So that's everything that's in repository secrets. Let's go into the code and take a look at what's in, let's say, is the main.tf. So all this does is create a resource group because I wanted to make it really simple. But you'll note that in the provider block for Azure RM, I have used OIDC set to true. You could also set that as an environment variable. It doesn't have to be set directly in the provider block, so that's up to you. But I just put it in there to illustrate the point that's how it knows to use OIDC for the authentication for this Azure provider. Let's see if there's anything else important in here. No, not really. Okay, so actually, I'm going to make an update here to the variables that will kick off a run, and then we can look at the run. We can look at the configuration for the GitHub Actions while the run is happening in the background. So I'm going to make a little edit here, and we'll just change the name of the resource group to today's date. And I'm going to commit this as a new branch. So I'll propose changes. And then I'm going to create a pull request, and the pull request will kick off an action. So that'll kick off in a second, but we can go back and view the code and go into GitHub workflows where the action's actually defined and look at what's in the pull request. That's still a little tiny. I'm going to bump it up one. Okay, so this is the action that kicks off with the pull request. So in the on portion of the configuration, this is any pull request that's targeting the main branch. Because the runner that's executing this action needs to interact with the token service, you have to give it explicit permissions to everything it wants to do. Once you add one permission, you have to add all the permissions it needs. It can't just make assumptions. So it needs write permissions to ID token to procure the token. It also needs, because of the way that you'll see the action setup, it needs access to write to issues, to write to pull requests, and also read the contents of the repository. So when the job initially starts, it's going to check out the code by using this checkout action. And then it's going to set up Terraform here. And right now I have it just installing the most recent version of Terraform, but you can specify in this action what version of Terraform you want to install. And then we're going to perform the login with OIDC. And so for that, we're going to use the Azure login action. And from there, we need to specify the client ID, tenant ID, and subscription ID. And it's getting all of those from the secrets that we've stored in this repository. Once it does all that, we're going to run just an AZ account show to just show that we have successfully authenticated and that we can list out one of the accounts that we have access to, or one of the subscriptions that we have access to. And then we're going to initialize Terraform. And in order to do that, we need to provide a little more information. We need the storage account, the container, resource group, and then we're going to grab the ARM client subscription and tenant ID from here. And then as part of the Terraform init command, we're going to specify a bunch of backend config settings that identify the storage account, the container name, and the resource group name. Within the backend configuration block itself, I have use OIDC enabled in the same way that I went with the provider. And I also have use Azure AD authentication so that it's actually using the account to authenticate to Azure storage instead of using like a storage key. Then we'll just do some basic checks, run Terraform format, run Terraform validate to make sure that the configuration is valid and formatted properly. And then we'll run a Terraform plan. And once that plan is, and with that plan, we'll need to submit some information in order to actually run the plan successfully. And then we'll add a comment to the pull request that includes the results of the format, the validation, and the plan itself. So that's everything that goes into the initial PR run. So it's using those it's getting that dynamic credential all the way up in this first step, well, not first step, but in this step here where we do the Azure CLI login. That's where it actually procures the token it's going to use to talk to Azure. And the run should be complete at this point. So let's go to actions. Yep. Okay. This is the action that ran. And so here's the AZ CLI login. And it says, hey, login successful. So that's probably good. And it also gives you the subject claim, but it actually obscures some portions of the subject claim, so you can't see exactly what it is. If you search around a little bit, a few people have found ways to show you the entire contents of the token within GitHub Actions run. Now there's sensitive information in there, so like you generally don't want to do that. But if you had to troubleshoot because you were getting login failed because the subject claim was wrong and you need to see that whole subject, that could potentially be a way to expose what that is. But we can kind of see it. It's the repository followed by this colon pull request is what's in the subject claim. So we get a good idea of what was in there and which credential it's going to use. And because this is a pull request, it could be a credential that doesn't actually have permissions to change anything. It only has permissions to read information from the subscription. So you could limit it in that way and use two different service principals. That's not how I have it set up, but you could, in theory, do it that way. And then we just run that quick account show command just to verify that we can now see the account that we want to work with. And then everything else seems like it's worked out okay. If we go back to our pull request that we opened, GitHub Actions added a comment into the pull request to give us the results of the various tests as well as an output of the plan, and lets us know, hey, you're just changing the name you're changing the name of your resource group, so you have to replace the resource group. You can't just rename it. So it's going to add the new resource group and destroy the existing one. So that's fine by me. I'll go ahead and merge the pull request, and that's going to kick off a second GitHub action. So let's go back to the code and check out that second GitHub action. That's this one here. This one kicks off whenever there's a commit or a push to the main branch. A lot of it is similar. The permissions are a little bit stripped down because it doesn't need to write any information to the pull request. But beyond that, it's going to do the same thing. It's going to check out its code, install Terraform, and then log into Azure using OIDC. Initialize Terraform again, because that has to be done on a new run, and then run Terraform apply with auto approve. Now, you certainly could stash the plan file somewhere from the pull request and then go grab that stashed plan file and use that for the run. And that's a whole debate that people sometimes have. We can get into that debate later if you want, but for this one, for purposes of the demonstration, I thought it would be a lot easier to just do Terraform apply with auto approve so we can, move on with our lives. So the action should be done by now. Oh, it's still running. Okay. See how far it's gotten. All right, it's in the Terraform apply phase. So it's currently destroying the existing resource group and then creating the new one. There we go. Yeah, still destroying. So when that's complete, my demo is pretty much finished. Trying to think of other things that we could show within here. Within the setup script, I actually have a second one here that's for a multi-environment setup. So if you wanted to go with a more complex example where you're using multiple GitHub environments and having actions kick off from there, you could set it up where you have basically the same GitHub action for each environment, but the credentials it uses for each environment is different, and that's stored in an environment-specific credentials for each environment. So that's a slightly more complicated example. I believe when I did it, I used 3 different subscriptions to just show that you could really do this, build it out in such a way that each environment is completely segmented from the other one. And it does work. So if you wanted to run through that, you can absolutely do that as well. The README is pretty detailed in what you need to do. And there's a second README inside the simple setup that will kind of walk you through what you need to set up on the GitHub side and the Azure side in order to successfully deploy the demonstration. And then you can just take this repository here and fork it into your own GitHub account. And then you would run through the setup process in that way. That's pretty much it that I wanted to show. I just kind of want to open things up for questions now regarding OIDC authentication, platforms that aren't GitHub actions, really whatever questions anybody has.
Go ahead, Jason.
Yeah. So we use Azure DevOps. How easy is it to apply this to Azure DevOps, either YAML setup or JSON setup pipelines on that side?
Yeah, Azure DevOps is a little funky because you generally use service connections to wire everything up. So service connections can use managed service identities on their own, which is kind of it's basically the same thing. So it doesn't need long-lived credentials. At least that's my understanding.
Would you recommend using managed service identities versus service connections? We create our service connections through a bash script that does it all, but it's a more complicated process. But would you recommend using service identities versus we manage service providers, so we deal with hundreds of accounts. It's a little more complex.
Right. I mean, the big difference, I haven't used Azure DevOps in a little bit, so I'm trying to pull this from memory. And if anybody from Microsoft knows this, feel free to jump in. But I believe when you're creating the service connection, you can select. Well, there was two different things. There was something called a service connection, and then there's another thing, right?
So to give you background, we create one service connection, but we scope it to all subscriptions within that. So all we need to do is just change the subscription ID, and it still remains within the same scoping, right? So now we just use one service principal to manage all the subscriptions. It creates for us an easier point of entry, but you can understand how it could become complex when you're dealing with multiple different SPNs.
Yeah, when you're creating the service connection, it gives you the option to create it as a managed ID so that it will handle the password in the back end. You
Okay.
can then go in after the fact and click on that service connection. And when you hit manage service principal or whatever, it pops you over to the Azure portal where you can grab the name, assign permissions, roles, whatever.
We create it all out of a build pipeline, so it would need to be
Mhm.
Azure CLI compliant. So we need to be able to do everything from a command line.
Yeah, I have not tried it that way. I've just done it manually through the DevOps portal.
Right on.
I did have, see if I can dig it up while we're talking. I did have an example of provisioning everything with Terraform to create the pipelines, the service connection, et cetera. And that gave you access to do some things programmatically. But I think that involved creating a service principal separately instead of having it automatically create.
Yeah, well, what this does is it essentially creates an array with all the subscription names and all the subscription IDs, and then it programmatically goes through each one and creates a service connection based on a vanilla template, a service connection template. And so it just uses sed to replace in line all of the information that you need, and then it just goes through a count until it exhausts the number. So any subscription that exists inside the Azure portal gets a service connection created for it. And then secondarily, another script runs that takes the YAML pipeline that would deploy the Terraform, and then it replaces the service connections in those as well with the ones that you've already got on an array. So at the end of it all, you're deploying your Terraform code into your Azure subscription without really ever having to touch anything. It's an end-to-end process, but I don't know how that fits in, because the problem that we face, right, is the storage of the secrets, because Azure DevOps does not have a really good way to access secrets that are not directly associated with the YAML bash code. If you're deploying secrets in, say, a second or third script, you don't really have a good way of retrieving those secrets back from the Azure DevOps pipeline. There's not a good way to get the agent to talk back.
I see. Yes, when you're nesting them that way.
Yeah, it becomes a more complex problem to try to retrieve or understand what those secrets apply to.
Yeah.
I was just going to say, Jason, if you want to bring that up in the Slack channel, we can kind of try to pull some folks in to see if we can get some more expertise and some more assistance for you on that, or some more recommendations for you on that.
Team managed device does not have Slack on it, so I do sincerely apologize. But yeah, it's something that I could definitely reach out for.
I know John's hand's up, but I also saw a question before from Aiden, so I want to read that first, if that's all right. So
I do have just a comment about the service principals you mentioned.
Oh, okay.
Managed identities in there. The managed identities, I believe, are using the managed identities of a machine that you are running in Azure. So it'll use the managed identity there if you're hosting your own agent. It's not that the pipeline gets one. I do have a blog post here from Microsoft last year. I don't know the status on this, but it does say that they're going to bring OIDC into Azure DevOps as well. So I dropped the blog post in here. I don't know the status of that, but that might be something that you'd use as well.
Thanks, Aiden. I appreciate that.
Yeah, I would love to see that too. I did manage to find it eventually. So I wrote, this is a while ago, but I wrote an ADO project module that would set up an Azure DevOps project. And as part of it, it would set up a service endpoint to Azure. And at the time, I think the only option to submit credentials was to submit a service principal ID and service principal key, which would be essentially just a username and password. So that's still requiring some static credentials if you were setting it up this way. But I would recommend just checking out this particular resource and seeing what other options it provides, because it may have been updated since then. Looks like project ID. Yeah, I don't know exactly what goes into this, but at the time, I think it was still relatively new and under development. So it's kind of like, we'll see how well it works. Yeah, there you go. I just threw that in chat, the actual resource that'll create that service endpoint with Terraform.
Excellent. Thanks, Ned.
Yeah, you bet.
Would you use the PAT token for the Azure DevOps? So the problem we have is, right, is that even to get in the beginning, you need some credentials to get stuff, right? So where do you put the cart and where do you put the horse? You're always going to have to store something somewhere to be able to pick it up for the next step. It's
where does secret zero live?
Yeah, where's point zero?
Right, and part of that's in Azure DevOps. Part of that is solved by storing information within a project, just using the built-in secrets engine. You could always move outside of Azure DevOps and store some secret information somewhere else, but then you still need to supply credentials that
you have to have a bearer token maybe, or something else that if that got out, it would be the same thing as having the static credentials. Yeah, it's hard to figure out the where do you make it dynamic, right? This is something that we've been talking about as well, as a security point of view, right? You make things dynamic enough that other people can't guess them, but not so dynamic that you can't use them. So yeah.
I would be really curious. I have not joined that Slack yet, and I think I am going to join it just so I can see where this conversation goes. Cool. How do I stop sharing? I'll figure this out eventually. Does anybody else have a question or? Oh, that's how I stop sharing. I figured it out. So smart now.
So I'll go ahead and present. And then there is a question from Aiden in the chat. So while I'm talking, you can pretend to listen while answering his question. So.
Blocker, Aiden, is that what blockers do you see enterprises from adopting and switching to OIDC?
Yeah, that's the one.
I think more of it's the actual setup is not that hard, as you saw. Like that part's pretty straightforward. You still have a service principal. You just have to create the federated credentials instead. So I think probably the biggest blocker is honestly process. You already have a process in place, and now you need to change that process. And there's usually some sort of momentum there. People have to understand, okay, well, if I'm going to change this process, what's the benefit to changing this process? What additional security, or am I going to be able to do things faster? So I guess that's probably the biggest blocker to someone adopting it. The other thing that I've worked with, and this is, we're going to get into a HashiCorp thing rather than necessarily directly Azure, but one thing that I've worked with a bit is the Azure AD service engine, or the Azure Service Engine in Secrets Engine in Vault. And if you have Vault in your environment, you could have it dynamically provision Azure credentials that have a time limit on them, and then leverage those credentials. And then you're getting into like completely dynamic. It gets a service principal on demand. That service principal exists for an hour, and then it's gone. And it's reliant on the permissions that you get and policies you set up on the Vault side. So that enables more of a self-service situation, where this still requires that someone needs to create that service principal ahead of time.
Awesome. Thank you, Ned.
Sure.
We have 3 minutes to get through about 15 minutes of content, so I will be... No worries. I'm just saying that as we will be speeding some things up for the last portion.
Just shows how interesting your presentation was, Ned.
Yes, it's not a problem, to be honest. It's more so you just have such an interesting piece that everyone wants to learn about. So, all right. For this specific week, I know that or this month, I know we normally try to highlight open source projects. This month, we have decided that due to the overwhelming attention that one certain project is getting, it would be better to highlight exactly what is going on there. And it is GitHub, Copilot, and all the other ChatGPT stuff that you may or may not have heard of. If you haven't read tech news in the past month, this is what they claim to be an AI-based pair programmer. Basically, you give it comments, and then it learns based off of your project context to continue to iterate and help you develop your own code. Full disclaimer, Mark and I are not going to do this demo just to try to sell you Copilot. We just want to take this time to talk about our findings with the tooling and what it can do and what we found that it can't do. So why don't I go ahead and share my screen real quick, and we can go ahead and see what we have. So, all right. So over here, I just have a completely empty main.tf. If you're not aware, the easiest way to get things going is you just type a comment, something along the lines
Can
of,
you make the text a bit bigger?
Yes, I absolutely can. Is that better? People?
Yep.
All right, one extra just in case. So if I say something like, write me a storage account, it'll go ahead and kind of show this little gray text. And then all you need to do to accept the changes is just go ahead and hit tab. Now, theoretically from here, you could also say, give me a resource group for this storage account. And it will give you the resource group. Before I hit tab on this, I will also note that if we name this something random and change these properties, it's not just learning based off of itself. It can also analyze the context. So it changes the name and location to match the actual name and location that's going on here. That is some of the basic functionality, but I think everybody is familiar with the basic functionality. Obviously, one other call out I'll say on this is if I say, write me a virtual machine, it's not going to, if it loads, because it looks like it's not in the mood to write me virtual machines. Well, when it works, it will give me the virtual machine resource, like a Linux VM. The issue is that it doesn't necessarily know what needs to be paired with that VM to make it usable. So it's one of those interesting ideas that, it can work in some simpler scenarios, but it might need a bit more assistance in something more complex. And that doesn't look like it's going to work. So I'm just going to switch over to my next thing. So over here, the second example I have is for something a bit more here. Hopefully people can still read this. For this specific example, what we have is the on the left, we have actually our verified module for AKS. So the team, if you're not aware, works on verified modules such as developing an AKS module that you can plug and play and that we maintain. So here, what we are simulating is that in your module, you are trying to basically add this node pools variable. So node pool, you can see, is a type of map and object. And over here on the right, we actually have the Kubernetes cluster node pool resource Go schema. So there's a few parameters here, like the name and the node count and the VM size. And Copilot actually is picking up on all of those. But you can also notice that with how this is defined, we actually don't get the same level of definition for something more complex like a kubelet config. That just doesn't the tool isn't even trying to do that here. If you want to, you can always go line by line and just kind of verify that what they're doing makes sense. VM size should be an optional string. And obviously, since I have the schema next to me, I can kind of guess and check my way through. For something like a kubelet config, though, it gets a lot more interesting because then it's kind of like, what do I do? But we actually have once you give it a second, you'll notice that it actually is able to load its own opinion on this. And then if you go ahead and you open the actual schema for the kubelet config, you could go ahead and basically define all of that yourself. That is my 10-minute demo shortened down to 2 minutes. So hopefully that was at least enough to get you an idea of what's going on with GitHub Copilot, its capabilities. We think it's useful. If you think it's useful too, give it a shot and give us some of your feedback and findings, because I think for us, because we want to make sure that if it's useful, that you have any issues with it, yeah, just talk to our team about it. We're curious as much as you are about what it can and can't do. So that is the brief demo on that. And I will...
It really is an exciting space, and it's fun to see how it really. I've used it a little bit. Ned said you use it pretty regularly, but it really seems like it would speed up your configuration. Just writing configurations would be much faster. So it's very cool technology.
Yes, I think it is definitely. Everyone is in their friends and their friends, people who don't even work in tech are talking about it, and that's how you know it's really caught on. So, all right, that is everything for today, but we have a little bit of time for Q&A, and by a little bit I mean -5 minutes. So if you have questions, we'll pause for 20-30 seconds if you have anything. And feel free to ask anything Terraform on Azure related in general.
Any support for auto manage coming?
We're working on it.
Okay, thanks.
We are definitely working on it.
So I will throw it there as well while we're working on it. Hopefully you are aware of the AZ API provider and your ability to use that to manage things that are not exposed in the Azure own provider yet. And if you have any thoughts or feedback on that, definitely let us know in Slack or in any other way.
Thanks, guys.
Any other questions?
I have not a question, but Mark, since you brought up the AZ API provider, we started using that to enable key rotation before the key rotation was enabled in the Azure Key Vaults. And so it was kind of handy to have that ahead of time. And then once Terraform got that update where we could do the key rotations, then we switched over to using the native or the Azure RM provider piece. But one thing we found was when we went to remove that AZ API piece, it gave, I forget the exact error, but it started complaining about trying to remove the provider, even though we had, at first we just commented out the code using the AZ API, but left the provider block in there so that it could reference it and hopefully remove it. But it kind of complained about trying to get rid of that provider, acted as if we just yanked it, kind of like what happens when you pull a provider out of a module and then update the module or that kind of thing. So it was just kind of an interesting scenario. Fortunately, we were able to just remove it from the Terraform state and then re-import the key rotation piece in there. But it was just something, I don't know if you guys have come across that, or maybe there was a weird niche or corner case that we hit, but it happened on every time when we were trying to remove that AZ API piece. And so
no, I have not heard about that, but thank you for bringing that up. We'll definitely look into that.
Yeah, great, thanks. That said, it
Yeah.
was handy and a cool tool. So sorry,
Awesome.
go ahead.
I was just gonna say, make sure to, if you have issues down the road, feel free to post in that Slack channel for the help. As Mark and I have mentioned, we try to monitor that and every single day and try to get responses or pull people from our product group to help with responses if needed.
Yeah, sounds great. Will do. Thanks.
Any other questions? All right, sounds like everyone's good. Thank you so much for joining. Appreciate everyone giving their time to us, and hope you're as excited as we are about all the different opportunities and investments and new things going on in the world of the Terraform on Azure community. So hope you all have a good rest of your day.
And thank you, Ned, again, for your presentation and walking us through the OIDC stuff. Super, super interesting.
Thanks for having
Really
me.
appreciate it, Ned.
You bet.
Thank you all.
Thanks, everyone.